All right, sounds good. We are back. This is the second session of part two, really, of chapter one. We're going to go through 1.4 and the rest as we go through it. But let's just backtrack just real quick here about this here. So chapter one is about elections. That's essentially what's it about. How do we make votes? How are votes cast? And we do it from political elections to school board elections to mayor elections like we saw last time. And so let's go back real quickly here. 1.1, what's it all about? Was just the vocabulary, the basics, just the basics of the vocabulary. What are we interested in? And there's two things we're interested in primarily is how the voting structure is made and which votes are going to be counted. There's that little piece, and it's all about rules. It's just how the rules are defined. And then 1.2, we looked at the one method, which is the most popular method called the plurality method. That was 1.2. And then we switched gears, totally different method. And we called it the Borda count method. Totally different, and actually gave us different results, completely different results. So we had president of the math club that turned out to be another person completely just because of the system that's made. All right, so we move ourselves to 1.4. And so we're going to cover two more sections here. So it's called the plurality with elimination. So back to 1.2, but we're going to think about that as a little elimination process added to the bunch. So let's jam. We're going to take a look at, do an example, and then we'll do a little bit of the exercises, something that looks like the homework assignments that are there. So let's jam. We have, there it is, plurality with the elimination method. In the United States, most municipal and local elections require a majority win to get elected. So only two candidates are usually accomplished unless there's a tie. And so I'll let you read that right there here as you guys are looking at it here. So 2 or 3 candidates is not uncommon for no candidate to be a majority. The preferred method is to do the plurality vote, but then have a elimination piece. Cool. Let's go with it here. And so if you think about it here, plurality with elimination, most elections are done this way. And so why is it made? So that so you have the Republican Democrat Party, you have the primaries. The primaries is in order to, in a sense, do elimination. And then from there, then you have the primary election later on, which is a runoff between that. Or you have mayor elections the same way. So the process, what's the process that we go through? And we'll do an example here in just a bit here. So first, you count first place votes. If a candidate has a majority, they're done. They're automatically declared a winner. If there's no majority, what we do is we eliminate the candidate with the fewest first place votes. And then we pass those votes down to the next candidate on those ballots. This seems to be a little bit off the way it does. So you actually are going to give ballots to the next person up. So we recount the first place votes. And if a candidate now has the majority, they are declared the winner. If no majority still wins, you repeat the process until you finally get a majority winner. And so you finally, sometimes you really, in a sense, get all the way down to 2 people. Let's do this. There's, again, some math involved. And let's just go through it. Let me see how this vote stacks up. So remember the math club election again. We have 37 members of the math club. They're voting for president. And so if you take 37, you cut it in half, makes 18.5. So in order to get a majority, you really need 19 votes. So then the question is, how do we get 19 votes out of all this? So let's go with it. Again, it's just another method. This is method number 3, right? So looking at this here, we're only looking for first place. First place was right here. We got 14 for A. I got 4 for B, 10 for C, and we got 11 for C right here. This is the first 11 for C, and then we have 8 for D. So let's see how this all plays out. And so if that's the case, we're looking at first place votes only. So if we count them, we got 14 for A, 4 for B. Sorry, let me go back real quick here just to make sure that we're looking at what we need to look at. Yeah, so A got 14, B got 4. So they're the lowest right here. That's the lowest. D got 8. That's the second lowest. And then C got voted twice. So C gets 11. So if we go over here, here's our point counts 14, 4, 11, and 8. So what we do is we eliminate the least vote possible right here. And then that guy, what happens to this guy? He gets, those votes get added to the next least placed person. And of course, the shout should be, that's not fair. Absolutely. Absolutely. So let's see what happens here. And so now we look at the next one here. So if that's the case, this now is sitting at 12, and we have 3 candidates, one at 14, one at 11, one at 12. Let's see what happens. So C now gets eliminated. They have 11. C is eliminated. And that 11 gets placed, and that 12 gets added together. So in round C has the fewest first place votes. It gets added to D. And now we have this right here. We have 14 and 23. Now D has the majority and is declared the winner. There it is, D, first place. A is second place, C is third place, and B was last. And so what happens is, this is a math election. There's only 4 players, but usually what happens is it becomes a truncated vote. So you give an election and you're ranked first, second, third place votes. That's what you do. And you eliminate until you eventually get to the exhausted list here. All right, so let's go back real quick here, just sort of see what's happening here. Let's go back to, so D was declared the winner with 23 points, right? But if you look back on the original vote, right? The original vote was D had 8. So again, like what are you talking about? He didn't even come in second place even, right? And so again, looks like it's not fair in a sense, an election, right? But this is just a rule. This is one of those rules that happen. What happens here? These are really just quick elections of things. But normally what happens is you rank them. You rank them, the choice is ranked, choice is voted upon, and then we go into it. Where is this used? There it is. This ranked election is used in elections for mayor and city council for these cities right here. I mean, me personally, I like the board account method because I think it seems to be, in my mind, it seems to be the most like the fairest way to do it, because you're counting all the points up and you're seeing which one would work the best here. So let's do an example here. So there was example in 2014. There's a total of 16 candidates that are running for the mayor of Oakland. And what happened was it took 15 rounds of elimination before a person was emerged. So the 16 candidates, only 4 had a realistic chance of winning. So to keep things in simple, we'll show that the vote count evolved once other candidates were eliminated. So what happened was 4 people really have majority. The other ones got like 10 votes, 4 votes. Their family voted for them only. And so what happened was, this is kind of like how it's stacked up right here. So this is 2004 mayor election for Oakland. So you have Dan Siegel, 17K, Jean Quinn, 18, looks like Rebecca, 18.6, and Elizabeth, 39.9. So the question is, does she have the majority vote yet? And no, she does not. That would not, so we will need, that's almost 40, that's, someone would need, oh, I gotta add these up here. But no, that looks like she does not get the majority vote. Let's add those up. And so what happened was the least person gets eliminated. Is that right? So that means this one, right? 18,000, no, 17, sorry, 17.4. Dan has the least amount of votes. So he gets eliminated. And those 17.4 thousand votes get added to Jean's votes here. So Jean bumps up to 20,000 votes. And notice, whoa, what happened here? Notice they're not eliminated exactly, right? Not like the simple example we had from the math club, right? So this one right here, it gets spread among the other candidates. And that's technically how it's done in real life. And so you have 2,400 went to Kwan, I guess I go by last names, 26 to Kaplan, and 38 to Schaaf. So notice it's proportional to what they had already. That's technically how it's done. So there it is. Then Jean gets eliminated here. And then with that, the proportional vote goes to the other two. And so we have that right there, now down to Kaplan and Schaaf has the majority of the votes. So notice that's a lot more fair than was presented before the math club, right? It's not so much as just you're given to the next less person, it's proportionally voted in as you get them. So again, what does this all mean? We're trying to calculate things that finally get to a 50% or higher. You're trying to get it to the majority. That's essentially what you're trying to do here. Okay, so let's go with it here. I guess we're going to do an example here. Just why do we do this here? So mostly the reason is because you don't have to have runoff elections. It's just one situation, it happens, and the rest is computed underneath there. And so there are one situation, however, where expense is not an issue and delaying the process is part of the game. So televised competitions such as Dancing with the Stars, Voice, American Idol, the longer the competition goes, the higher the ratings. So then what happens here is they vote, and the least person, they get taken off the show, right? And then you have the next week's crowd winner, right? So instead of just crowning a plurality right at the beginning and who won, it's repeated week after week after week until you finally get a winner. Okay, let's do some problems here. So there it is. We have ourselves an election for 4 candidates, A, B, C, D. What is it? Alicia, Boris, Carmen, and Dave. So question is this: according to the plurality with elimination, using this process, can we find the winner? So we don't care about 4th place votes, 3rd place votes, 2nd place. We're only caring about right here, this little piece right here. So for A, looks like A has 9 points. B looks like has 11, 13, 14. C has 0. And D has 4. So D is the lowest one at this point, at least so far. I'm gonna have to play it like this right here. So we go with it here. So if that's the case, what we do here is we tally all the votes up. C is eliminated. Done. We'll go step by step here. So nothing added to anywhere. So now look at the next place votes here. So we got D right here. This is 4 right here. 4 is going to be eliminated, and those 4 are going to be added to the 9 over here. So in that case, A comes in, and looks like 14 and 13, B is still going to be the winner. So the final ranking is B, then A, then D, then C. Gets you to a ranking order here. Okay, so round 1. So round 1, what happened was this guy got a majority vote already. It was more than 50%, so he won right in round 1. Okay, a little bit more complicated here, just again, so you guys can do the homework. Let me flip my page over here. All right, so let's go with it here for an election. 5 candidates again. The number of voters in the election was very large, so the columns of the preferences schedule now show percentages. So these are percents rather than actual numbers. So this is 25% of the votes. This is 21% of the votes. So we're talking about state elections where there's thousands upon thousands of votes. So let's go find the winner of the election, find the complete ranking of the candidates. So let's go. The first place votes only count. So A has 12, B has 15, C has, wow, this looks like this is 35, 44, 52. So C has 52 votes. D has none. So let's go with it. So first round, round one only. This is percentages, and C is above 50%. They are declared the winner. We're done. There it is. Just needed one round for this to happen. So now let's go for the ranking. Ranking goes with D being eliminated, no votes added anywhere. Next, the least amount, so 12, this is the lowest. That 12 gets eliminated, and those 12 points go on to B. So 12 plus 15 is 27. 27 is going to be eliminated, so B is eliminated. 27 points go to E. Oh, sorry, no, I'm sorry, going backwards here. So 27, no, 21 is lower than 27. Sorry about that. 21 is eliminated, so E is eliminated. 21 points go to B, which gives you 48. So what's the process? C is first place, B would be second, E is third. A is fourth, and D with 0 points is last. All right, so I'll go back here. Hopefully that was good there. Makes sense. All right, let's go on to the next method here. So the method of pairwise comparisons. Okay, there's going to be a little bit more math involved in this one. So again, another method is used, and these are elections. And I believe, if I'm not mistaken, I believe the NFL draft uses this election process. This is how we do it. So let's go with it. So method of pairwise comparisons. So one of the most useful features of preference scheduling is it allows us to find the winner if you compare each of the candidates against themselves or against others in the group. Sorry, not themselves. So given any two, you're just going to call out X, and then you're going to call out Y, and then you're going to count the tabulations between them. And this is called the method of pairwise comparison, Copeland's method. So here's where the math begins, because you have to figure out every single possible pairing between the candidates, and then you have to consider who's going to win. Winner of each pair gets 1 point. The loser receives 0 points. In the event of a tie, they get half points. And at the end, after you compare every single person to every other person, the person with the most amount of points wins. So let's try one. Let's try one. Easy numbers here, though. Let's go to the Math Club election. So we're going to compare every single candidate against the other candidate. So let's go with, let's list. So first things first, we have to list all the different possibilities here. So I got A going against B, right? So let me list it out right over here. So A versus B, then A versus C, A versus D. So we got all the comparisons between A and all the other pieces. And notice what we do is we move on to C, so to B. B does not need to be compared to A anymore because it was already compared over here. B doesn't be compared to itself, so just B versus C and B versus D, and then eventually it's just C versus D. So notice the list keeps shrinking each time you go down on the column. So the first column ranking for the preference schedule represents 14 votes for A, is ranked higher than B. The remaining 23 votes are for B. They're ranked higher than A in the last 4 columns of the table. So the winner of the comparison is B. So let's go back again, just the math involved into it here. So right over here, A versus B. Go back up here to the preference here. All right, and so the question is, where does this 23 come from? Because this 23 is listed here. So let's see where that 23 came from. So you guys know how to do it on the homework here. So go back over here. And what we do is we just look at each column right over here, and we see who wins who. So in the 14 points, A wins out B because it's higher in the column here. So A gets 14 points. You go into the next one and 10 points. Oh, look at this. Notice B is higher than A this time. So B is going to get 10 points. You go on to the next one. B is again higher than A. It's going to get 8 points. And then over here, B is also higher than A. Oh man, so you just look at the columns and you add up the column point totals of the ones where the one letter is higher than the other. So B over here. So really, notice A wins here and B wins all the other columns together. So in this case, if you add 8 plus, so 10 plus 8, 18, 22, 23. And so again, just a real quick here, where these numbers are coming from. That's where that little 23 came from. So look at the columns. Let's do one more, and then we'll kind of see how it goes. So A versus C. And now let's do two more, just to kind of, so A versus C, very similar. Let's go back to our little point system here. A versus C, so we're comparing A to C. So on the ballot that had 14 of them, A is going to win C because it's higher, ranked higher. The next one, notice, yep, C now wins A because it's standing higher in the poll. So C gets 10 points. C gets another 8 points because it's ranked higher. And C gets another 4 points. And then C again gets another 1 point because it's ranked higher. So again, just like B, C tabulates all the other points as they just looking at A and C. Let's do one more. Let's go with C versus D. And let's see if our point total is correct here. C versus D. C is higher than D. That means C gets 14 points. C is higher than D. C gets another 10 points. So now C has 24 points. Oh, D comes back at it. Now D has 8 points. D again is higher than, so there's 12 points right there now for D because D is higher. So 8 plus 2. And then, oh, C wins out on this one here. So D gets 12 points. And C gets 12, 14 plus 10 is 24, plus one more is 25. So 25 versus 12. So hopefully you know where those numbers are coming from now. So there's this last one. There it is. C gets 25 points, D gets 12. So C is the winner here. So this is the method of pairwise comparison. So now the question is this: winner, total up all the winners that we have here. So it looks like A gets 0, B won twice, C won 3 times, and D won once. So the ranking is C is first place. So Carmen gets to be the president. Boris, second place. Dave gets second to last place, and Alicia is in last with 0 points. So how funny, how funny is that? When A actually won the most amount of points this way, right? So we have just this whole concept of there's no such thing as fairness. There's just rules, how the rules set up for the election. That's really what we get to. All right, so let's go with the rest of it. And so if you've been paying attention, of course, it's set up in a certain way. This is kind of like now an overview of the stuff we started all the way in chapter 1.2. So remember the plurality vote. The plurality vote, A is the winner. The board account method, B was the winner. Plurality with elimination, D won it. And then the pairwise comparison test, C won it. So notice, just by the different method, you got different voting systems. You have absolutely different winners here. So that's the craziness about elections. It's set up, the rules are important. The counting methods are important. It's not so much as it's fair. Okay, so pros and cons here. Although the method of pairwise comparison is pretty good method, in real life elections, it's not used as much as the other 3 methods we discussed. And the next example will illustrate one interesting and meaningful application of the method, the selection of the draft choices of the NFL. So NFL teams are extremely secretive of how they make their draft decisions. And so let's see, the election is made up, of course, here. So can't use real stuff here. So the Los Angeles, and it should be the Rams, not Laxers, because that's Lakers. That's basketball. Didn't make up this. This is all the publisher stuff. This is not me. So the newest expansion team in the NFL are awarded a first pick in the coming draft. The team's committee, made up of coaches, scouts, team executives, are narrowed down a list of 5 candidates, A, B, C, D, E. After many meetings, the draft committee is ready to vote on the team's first pick of the draft. So the election is to be decided in the pairwise comparison test. So here it is. The coaches got together, the committee members, everybody else got together, and here's the voting that has been done. And so let me get the names here real quick here. So Allen, Byers, Castillo, Dixon, Evans. There it is. Okay, so the means comparison test is we're going to compare. A goes to A compared to B. And so let's go with this one. Let's do this one together here. Let's see. A compared to B. That's what we're going to do. So A versus B. On this column, A wins. A gets 2 points. And B versus A. Oh, B wins this time. B wins another time. So that means B has 10 points now. 10 points for B. Oh, 11 points for B. B wins again versus A. Oh, A now versus B. So that's 11. So A finally gets their third point. Third point for B. And then, oh, major win right here. A wins. So 3, 4, 5, 6, 7. So it really comes down to this one right here. 7, who wins here? So B wins right here. So B wins 4, 5, so 15, I believe 15 points here. So the first one, yeah, 15 versus 7. Ding, 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 ding. So the winner is B. This one's the unusual one. We got to do B versus D. B versus D. So because there's going to be a tie. First time we see a tie. So let's count up the tie. So B versus D right here. So this one, if you keep track, if you want to keep track on a sheet of paper, that's fine. D gets 2 points. B gets 6. B gets another 4, so he has 10 now. 11 right here for B. So this guy's at 11 points now. And then we go with, oh, D wins out this time. So Dixon wins out. Now he has 3. D wins over here. Major difference there. Someone didn't like B at all in this one here. 7. So that's 3. That's 7 now because it's plus 4, 7. And then D wins out here just barely, but it wins out. Ranked 3rd instead of 4th. So that makes 7 plus. Oh, that's 11. So on the column rankings, B as in boy or Byers got 11 points, but so did Dixon. They got 11 points too. So it's a tie. So right here. So that means they get half a point each. So if it ties, they get half points. So tally up all the winners, and looks like A wins the day with 3 points. B comes in the second, 2.5, then C, then D, then E. Okay, means comparison test. This is probably the most of the math you're going to have to do on these here. All right, Allen wins with 3 points. Notice that things are a little trickier here. Allen is the winner of the election, even though the draft committee prefers Byers to Allen in a pairwise comparison test between the two. So yeah, that's crazy. If you just, Allen won the overall point total against everybody. But if you look back, Byers, if you just go A to B, only A to B against themselves all the time. So this right here, you notice that Byers would have won if it was just against A and B, but then A wins over here. So it almost feels like awkward that you pick a person that compared to the loses, but then you wins on the other side. Okay, so that's the weird drawback to the pairwise comparison test. So compared to other methods, the pairwise comparison takes a lot more work, right? There's a lot more calculation. Each one requires a separate calculation. And then at the end, there's another calculation. So what tends to happen is, unless you have some kind of computer system that's crunching the numbers, we technically don't do this on a sheet of paper, especially when there's a whole bunch of candidates. All right, so then we have this little interesting thing is just the whole number of how many calculations you need. So if you have 10 candidates, you're going to have to do 45 calculations to make that true, right? We just did, let's go back real quick here. We have how many candidates here? We have, yeah, we have 1, 2, 3. There's 5 candidates here, right? So according to this little rule, it says like how many calculations? 5. So we had to do 10 calculations to make this happen. So let's see where the 10 calculations came from. So if you separate each one of these here, right? A goes to B, A goes to C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had to do 10 calculations. That's a lot of calculations for just 5 players. Because then if you think about it, how many players are in the NFL draft, right? How many candidates are looking at to be selected and other things. So it tends to be just huge amount of calculation. So this is going to be on the homework as well. It's going to ask you how many number of pair comparisons do you need for, and then it's going to tell you like how many, like 30 competitions or 30 players. And you're just going to add this little number. It's going to be 30 times 29 divided by 2. So there's the little, so let's go to some exercise problems here. So again, a lot of calculation here. I'm going to look at that time here just to make sure we're all good with time. I do want to go through these examples because the examples are very close to the homework assignment as well. So I do want to go through those just to make sure you have what you need for the homework. So the preference shows an election for 4 candidates. Again, Alicia, Boris, Carmen, and Dave. Use the method of pairwise comparisons to finish it up. And this one, if you want to pause the video, if you're looking at the recording of it, if you want to pause the video, try it yourself, that's perfect. That's exactly what you should do in this case scenario. We went through the lesson. If you can stay ahead of me, that's perfect. Okay. If you just want to watch it all the way through just to make sure you got it correct, that's fine too. But the reason why I put these examples up here is for you now to sort of try it yourself, and I give you the answer. That's the whole point here. So find the winner of this election, pause tape, try it yourself, see if I get the same numbers as you later on. Find the complete ranking of the candidates. So let's go with it here. So again, we have 4 candidates. A is going to be compared to B, A to C, A to D, then B to C, B to D, and then C to D. So let's jam with it here. So let's see what happens here. So if you were to compare A to B, you should have 50 votes, and then 29 of those votes went to A. So it should have been 29 versus 21 if you did the correct, again, after pausing. A versus C, you should have got 21 versus okay, sorry. So 29, so 50 for A, just real quick, just so we know, for 50 to A, and B got 29. So if you did the work on a separate sheet of paper, you should have got 50 versus 29, and A wins. A versus C, you should have got 39 for A, 40 for C, and C wins by 1 point. So C gets 1 point. A versus D, A should have got 49 points. D should have got 30, so A wins. A gets another point. And then the rest of them, here it is. B goes to C. B gets 18 points. C gets 61, C wins. B versus D, B gets 50 points. Dave gets 29 points, so Boris wins on this one. And C versus D, Carmen gets 50 points, Dave gets 29, C wins, C gets a point. So point tallies here as we calculate them up. It looks like A gets 2 points. There's 1 point for B, 3 points for C, and 0 points for D. C is the winner. Complete ranking. C goes first, A goes second, B gets 3rd place, and D winds up with 0 points for last. So again, the means comparison test. All right, I got two more problems here. And again, this is where you pause the video if you like, try this yourself, and then come back to see if you get the same exact answer that I did. So the first example we did, that was in terms of raw numbers, right? This one here is just slightly different. This is now in terms of percentages. That's the difference there. So the number of votes in the election are very large. There's thousands upon thousands of people voting here. So instead of looking at the votes themselves, on the homework as well, you're going to look at percentages. Very similar to points, right? So find the winner of the election using the method of pairwise comparison. Please stop the video right now. Do the work yourself after you've done it, because I'm going to give you the answer here in just a bit. All right, hopefully you took the time to pause the video. And here is the answers here. So now the only difference between the previous example is the fact that we're looking at percentages, and there's your percentages. Okay, pause the video if you like and take a look at to see if your numbers turn out to be the exact same as my numbers. All right, and then tallying up the point totals, there it is. So A got 0 points, B ended up with 1 point, C ended up with 4, D gave us 2 points, and E comes in with 3 points. All right, and the last one here. This one a little bit different. It is on the homework, so I just want to make sure that we are aware of this one here. So let's see. An election with the 6 candidates, A, B, C, D, E, and F, is decided using the method of pairwise comparison. If A loses 4 pairwise comparison votes and B and C both lose 3, D loses 1 and ties 1, and E loses 2 and ties 1. So this is almost like a little puzzle. It's like how many pairwise comparisons does F loses? And so we know the totals for the other ones. We just, for some reason, don't know the totals for F. They got lost. So the question is, if we know all the other totals, is there a way to figure out what F had? I think so. And then afterwards, can you find the winner of the election? Who actually won? So let's see. And then think about losses, right? And then think about winners here. So pause the video if you like. If you want to think about how you would solve this problem, go for it. All right, we're back. So let's see. Let's go. I'm going to just start off with the answer here. So question is this: how many comparisons does there have to be? And so remember that little number that we talked about? If we have 6 candidates, let's go back up here, 6 candidates, right? 1, 2, 3, 4, 5, 6. We know that little number. That little number says 6 times 5, or n times n minus 1 divided by 2. So we should have had 15 pairwise comparisons. So now the question is, how do we find out how many F1? So F1 must have 1. 15 would be the total, right? And all we do is we total up since A loses 4 pairwise comparison, right? But how many times A would have been compared? A would have been compared 1, 2, 3, 4, 5, right? A would have been compared to B, to C, to D, to E, and F, right? So if A lost 4 of them, that means A only won 1 of them, right? There's only one time that A won. If A loses 4 times, that means that he won once, right? If C and B loses 3 times, that means they won twice each. So B gets 2 points, C gets 2 points. D loses 1 time and ties 1. So loses 1, ties 1, that's 1.5 losses. That means it won 3.5 times. And E loses 2.5 times So that means it won 2.5 times because the total has to be 5 per each. There you go. I'm so sorry about that. So there it is. Grand total had to be 15. Here's the number of wins for A, the number of wins for B, the number of wins for C, the number of wins for D, and the number of wins for E. And then if you do that and subtract from 15, you get 4. So then you say, okay, that means F won 4 times, and that means F lost once. And if that's the case, who's the winner? F is the winner with 4 points. And done. There it is. Okay. I'm going to pass through that real quickly here. So last section for chapter 1 is the fairness criteria, Arrow's impossibility theorem. So it's a little bit long, but not much math to do as we're sort of looking at this. So let's jam with it. So first things first, what is it? So we examined 4 different voting systems in detail. But first things first is we do not have time to discuss all of them. There's so many voting systems. Literally, if you can think of a way to make a method to count votes, there's a new system. So the question is, which one's the best? Which one gives you the fairest amount? And we say, not really. There's no best one. And so there's Borda, right? Remember the Borda counting method? He is the French mathematician. And as you're looking at elections, he said, hey, no, the counting method should be the best one, right? And remember the candidate we talked about, the Condorcet candidate? This is because of this one right here, a philosopher and a mathematician. He said, hey, look, there's a candidate that actually can win, but because the methods are made in such a way that this is actually the better candidate, but he's not going to get voted upon because of that. So we come to Arrow's impossibility doctrine or theorem. So in fact, we know that there are limitations to all voting systems. It's very important in the famous discovery known as Arrow's impossibility theorem. So in the late 1940s, the American economist Kenneth Arrow turned the question of finding an ideal voting method on its head and really just asked, what would it take for a voting method to be at least a fair voting method? So here's Arrow, Kenneth Arrow, there it is, young age, and as he got older, there it is. And so you could tell that he's going to be a mathematician, right? He's going to be a political theorist as well, right? An economist, and also a writer. So no voting system is fair. But the question now becomes, what would it take for a voting system to be at least counted as at least fair? Like, hey, this is at least, it's not destroying anything. And so let's go with it here. So to answer the question, Arrow sent forth a minimum set of requirements, and it's called the fairness criteria. So first things first is majority. If you have a majority candidate, that person should be elected right then and there because they won the majority of the votes. You're done. So then you have the Condorcet criteria. So yes, if you can find out if there is a candidate who meets this description, then that candidate should be the winner of the election. And if this is stated, candidate X is the winner of an election, then X would still be the winner had a voter ranked X higher in his preference ballot. So technically, if you move this candidate up on the higher rankings, the candidate would not be able to hurt this candidate by moving up the ballots. So there's the monotonicity criteria. And the independence of irreverent alternatives. So if candidate X is the winner of an election, then X would still be the winner had one or more of the irreverent alternatives, basically losing candidates, not been in the race. So they should have won by themselves and not hurting that candidate. So there it is. That's the fairness principle. And so let's go through just a quick example. I'll go through some exercises with it here. So we're going to do some counting here, right? So there it is, 3 ballots or 3 types of ballots come in. A, B, C, D is ranked first with 6 points. B, C, D, A, 2 points, and C, D, B, A with 3. So question is this, who wins? So notice for first place votes, if we think of the plurality vote, right? A gets 6 points, B gets 2, C gets 3, but the grand total is there's 11 points over here, right? So 6 is the majority of 11, A wins. A would be the majority candidate right then and there. When you use the boredom counting method, though, we get A gets 29 points, B gets 32, C gets 30, and D gets 19. So B would have been the winner. So that means, we have a violation of the majority candidate. So A should have been in the majority, but doing the board accounting method, we get a new winner. That's our problem. So let's go with the band going to a bowl scenario here, right? So under the majority vote, and the plurality vote, just right here only, right? R gets the plurality, the Rose Bowl gets the plurality. But we already calculated, we did this before here. We find out that if you actually do the most pairwise comparison test, you find out that the Hula Bowl actually wins out. So do we have a little problem? Yes. We have the fact that the Condorcet candidate should be the winner. So each of the voting systems, as we looked at before here, right? And so all these systems that we looked at is the fact that the plurality vote, it gets you the majority and the monotonicity vote. The board accounting method, it in a sense, would always keep in mind the monacity vote, but it could break or it could violate these other ones here. So plurality with elimination, you'll always get the majority candidate, but you could violate the criteria here. And the pairwise comparison, look at this one. It's almost like it is the safest route, right? If you pairwise all the comparisons here, but it'll still lead you to violate the independence or irreverent alternatives. So what Arrow ends up doing is just to say that the 4 ones that we studied, they could possibly violate the fairness criteria. And so if you have 2 candidates, obviously whoever's the majority person is going to win. If you have 3 or more candidates, it is mathematically impossible for the voting method to satisfy all 4 of the fairness criteria. All right. And just a little thing of the author here. It says, no matter how we try, democracy will never have a perfect fair voting system, and the potential for some form of unfairness is really built into every single election that has more than 2 candidates. This does not mean that every election is unfair or that every voting method is equally bad. It really just means that we should stop trying to improve the quality of our voting experience, but really set down some really thoughtful rules when we do them. Okay, so conclusions of the chapter itself is elections are ubiquitous. Yes, they happen all the time, right? Even if it's voting for a middle school basketball team, they're ubiquitous. We vote all the time. There are many voting systems. We looked at 4 of them. And then different voting systems could produce different results, as we saw. And the whole concept of fairness, or getting exactly that, is elusive most of the time. So let's just do some examples here. Let me see how much I have set up. think I got 3 set up here. So illustrate why the Borda counting method violates the Condorcet criterion. So this one again is the last section of a math chapter. And what tends to happen is those tends to be the more difficult ones. So kind of be mindful of that here. And we're kind of coming up against time for our office hours too. So I'm going to go a little bit fast. If you can do this yourself, go for it. You can pause the video, go for it. If you can't, let me just kind of try to go with it here. So I'm going to give you the problem, try to do it, try to think through, go back to the chapter if you need to, and go for it. Otherwise, I'm going to give you the answer afterwards. Okay, let's go with it here. So remember, trying to figure out, let's go back real quick here, why the Borda counting method violates the Condorcet candidate. Yes, so we're going to have to calculate the Condorcet candidate. So first we determine the winner using the Borda counting method. Here it is, A. Should give you this much points if you look at it. B, C, and D. So go back to the Borda counting method. That was 1.3 if you forgot how to do that one. So according to the Borda counting method, yes, B is the winner with 32 points. However, candidate A has 6 of the 11 votes. He's the majority candidate and beats all the other ones in a head-to-head comparison. So if you look back just at the first place votes only, right? First place votes, forget about everything else. A has 6 points, B has 2. So even if you add these up together, that's still 5. So the popular candidate is A, but using the Borda counting method, it is B. So there it is. You're going to get 2 different results. All right, so then this one, illustrate why the plurality method violates the irrelevant, independence and irrelevant alternatives criteria. So then I'm going to look at that to see what that is. Go back in your notes if you need to sort of see what that is. Find the winner, then eliminate F and see what happens here. So let's go with it here. So the winner of the election is candidate R using the plurality vote, right? They got the most amount of votes and done. And so what happened was, if you get rid of F, and so real quick here, that was the Fiesta Bowl, is that right? Fiesta Bowl. Notice what happens here. F is eliminated. So what happens is the O and the S kind of bump up. F is eliminated here, so the R, the Rose Bowl, bumps up. And F is eliminated here, so all of these go up. So notice H is going to go into this little 3 spot right here. So now H actually has the majority. Now it has 51. They got 51% of the vote, or 51 votes. And now R has 49. So that is done. So it just means this. The last criteria says if I eliminate the candidates, it's not going to produce a different winner. In this case, the independence and irrelevant alternatives criteria got violated. So explain why the method of pairwise comparison satisfies the Condorcet candidate criteria. So there it is. The X is the Condorcet candidate, then by definition, X wins every pairwise comparisons. Therefore, the winner under the method of pairwise comparison. So the Condorcet candidate is that. He's the winner of the pairwise comparisons test. Just a subtle definition there. All right, and with that, we are done with chapter 1. Hopefully this video made sense. I do have students, many times what they'll do is they'll actually just watch the video twice. They'll watch the video once just to get the sort of the flavor of it. They'll start on the homework. And as they go through the progress of the homework, they're kind of like stuck in a few problems. They'll watch it again and like, oh yeah, that's right, that makes sense now. And go from there. All right, well, hopefully that gave you enough information to go with the homework for chapter 1.